Good afternoon, everybody. Almost said good morning, it feels like morning. So my name is Bert Bos, I work for W3C in France. Come in. And this talk will be about how W3C works, what it creates, how it creates, what it creates, and of course also how you can work with W3C, influence its specifications. W3C, the World Wide Web Consortium, is now a little over 11 years old. It was created by Tim Berners-Lee in October '94 at MIT in Cambridge, Massachusetts. And I'm working in the French side in the south of France, in Sophie Antipolis. We also have a site in Tokyo and various smaller offices in many countries, also here in Germany. So over those years, now more than 11 years, the web has changed quite a bit. The basic structure is still there, but it's become a lot more complex with a lot more things added on top and to the side. This is more or less how it looks in '95. It's a bit simplified. I left out a Gopher and the FTP and the NNTP and other things that already existed. The basis is the URL that allows you to address everything on the web. On top of that is a protocol, HTTP or other protocols, but HTTP is the most used one. On top of that, a couple of formats, HTML, of course, for text, CSS for style, PNG for bitmap graphics, having GIF also, and JPEG for photographic images. That was more or less it in '95. There were people using sound and video, but not a lot. This is well, a partial graph of what it looks like nowadays. I looked on the W3C site for the best looking schema that we have, and I found this one. It's not complete, there's things missing, but you get a bit an idea of how much more is going on now than there was 10 years ago. So you see at the basis there's still URLs are now called URIs, but it's basically the same thing. HTTP is still there. XML has been added, lots of things on top of XML. HTML, there's now XHTML. Well, HTML works also, of course, but the new one is XHTML. CSS is still there. SVG has been added, Smile, Xforms, lots of things. And this graph, it looks nice, separated in various columns, interaction, mobile, voice, web services. Of course, in reality, it's not so separated, it's all integrated. And if you look here on the right, for example, privacy, security, it's not so that you either do something private and secure or you do it interactively. That, of course, is not the case. Privacy and security is integrated with everything. You have to deal with that, with all interaction, whether it's via HTML or via voice or business to business, everywhere. Here in the middle is a big wide oval that says device independence, quality, internationalization, accessibility, to indicate that there are concerns, well, actually like privacy and security that have to do with everything, that are pervasive for all protocols and formats. So you can imagine that there's a lot of communication, a lot of coordination going on to make all of this work together. So the basic way we work in W3C is try to get people to agree on something. It's not so that somebody creates something and imposes it on everybody else. There's also not a vote where the majority decides. The goal is really discuss as long as it takes to get people to agree. Consensus doesn't mean that everybody thinks it's a good idea, but it means at least that nobody disagrees anymore. Sometimes we say the magic word is, I can live with it. So when you reach a point in the discussions where the last objectors say, okay, I can live with this, then we know we have something that we can promote to a standard. And the reason we do all that is, well, the motto of W3C is leading the web to its full potential, where it's on purpose that leading is an ambiguous word. It's both being in front, being at the forefront, and leading the way, but it's also guiding. It's not only being the first to do things, but also helping people. So the question then is, of course, what does it mean, full potential? And, well, for W3C, basically, that means semantic web. It's probably a term you've heard. It's become quite fashionable over the years. Actually, the first time Tim Berners-Lee used that is more than 10 years ago, somewhere in 92 or so, I think he first wrote about that. At the time, nobody picked it up. But nowadays, people do. There's lots of research projects around semantic web. Semantic web in web services, semantic web for knowledge representation, everywhere. Of course, that doesn't answer the question what it is exactly. Semantic web is an abstract goal. It's not so that we can say, okay, if we have these features on the web, then it is a semantic web. There's not a concrete goal to reach, and then we say, okay, we are ready. It's sort of an ideal, something we strive for, but it can always be improved. Semantic web means the web contains meaning, not just data, but actually meaning. And meaning in this case means meaning that is available to computers. So rather than needing human intellect to make sense of what you see on the web, you can ask your computer to make sense of it and give you the results, summarize it, transform it, whatever. Imagine that you have a human assistant, somebody who helps you with everything. You can ask him or her, what is the cheapest flight from Berlin to Paris? And this person will go on the web and find it for you. Now imagine that instead of a person, you can ask that of your computer. And the computer will be able to find all the information on the web, interpret the various sites that are out there, compare the information and give you the result. Of course, we're not there yet. All the information is there in some way, but it's hard work to compare things, to transform it to the format you want. Some is in table format, some is in images, some use different languages. It's hard work to get the meaning out of the information, out of the data that's there. So semantic web is a final goal where the computer can do more with the information than it can do now. And of course, there's always more. Even if we improve things a bit, there's more after that. So another way to see that is to say it's about reusable information. It's about information usage in a different way than the way it was first created. This graph, yeah, I know you can't read the text, it's too small for people, at least for people sitting in the back, but it looks nice anyway, does it? I'll explain it a bit. It's a graph that I use a few times, I've used a few times in talks earlier. It's the idea of communication. At the top is somebody who has an idea, who wants to communicate that. On the left side is a black arrow that goes down to somebody else who interprets the communication and maybe then decides to become author himself, and via the arrow on the right, he becomes somebody who himself has ideas and tries to communicate those. And in the part here, this one here says representation. The idea has to be represented in some way so that it can pass over the web in some format, an HTML, XML format, whatever. You have to choose a representation for your idea. Maybe it doesn't work quite correctly the same way. You have to think about it a bit and try again. So that's why there's a circle here. You may have to try several times to express your ideas the right way. It's transported over the web. Maybe during the transport things happen to it. It gets filtered. It gets combined with other information. It may be summarized, condensed to a smaller format. It may be stored for a while. The web is not a real-time communication system. It's store and forward. It's archived. You can go back to something long after it's been first put into the web. It's archived. Finally, it comes here. It's displayed. Maybe also the display isn't right the first time. It gets different views. It's maybe displayed in various different ways. And then what has been displayed is interpreted. So all these smaller circles here indicate that information has to be processed in various ways. That's the reuse that's going on. And to make that as easy as possible is the goal of the semantic web. So a few examples to show how the various things W3C creates fit in that architecture. SVG is one of those. SVG is scalable vector graphics. It's a way to encode diagrams, graphs, all kinds of images as a set of objects. It's an XML format. And that means the objects are there. You can annotate the objects in the image. It's not a bitmap. It's not a photo. It consists of just pixels with no relation to each other. It's actually a set of objects expressed in XML, so in a text format, and you can inspect it, you can change it, you can add information to it. Of course, in the name it already says it's scalable, so it works on a small screen or on a big screen. It doesn't degrade when you enlarge it like a photograph would. And stylable, so the structure is there. You can change the colors, you can change the fonts, you can change the thickness of the lines or the style of the lines. It's still the same structure, but it looks differently, so it's stylable. Of course, it doesn't help to adapt something to a non-visual medium. So this is good for big screens, small screens. It doesn't help you a lot if you don't have a screen at all. You have to go further than that. Another example is a project we started this year, a mobile web initiative. It has two working groups in it who look at the problems that mobile phones have, in particular, accessing information on the web. So trying to find the problems, the characteristics of the various devices, trying to come up with guidelines for how to create content, how to create web pages, in such a way that they are not only nice looking on the web, on a big screen, on a PC, on a desktop computer, but also on a mobile phone. We also work on tests and validation, checking that content and software actually works on mobile phones. That's another aspect of this reuse. It has to be available on big screens, on large computers, but also on small ones, on mobile computers with small screen, a few pixels, few colors. And not only the display is different, but also the input, of course. You don't have a 100-key keyboard. You don't have a mouse. Maybe you have a stylus to write. Maybe you have a tiny keyboard. Maybe you don't even have that. You have just the number keys and a menu key. You have to interact with only that. But you may have something else instead. Voice, for example. You may be able to talk to the machine, and the machine may be able to talk back to you. So not everything has to be visual and keyboard-based. There are ways to transform the information. If the information is structured correctly, then it can be transformed. A project that we have had for a long time already is the Web Accessibility Initiative, which deals with accessibility of information for people with handicaps. It's basically the same thing as the access for small devices. It's very much the same techniques, the same guidelines that people have to follow to make information available for people that are blind, that can't hear, that have problems moving the mouse. all kinds of handicaps, people who are dyslexic, who can't read long words or have trouble with long paragraphs. There's all kinds of stuff. People that may have trouble with things that blink, for example, certain frequencies, people can't handle that. They may lose consciousness when they see certain frequencies, for example. So if the information is available in a sufficiently abstract way, sufficiently structured, it can be transformed so that everybody can access it, either via a speech synthesizer, via Braille device, or by enlarging the text, removing the colors, changing the colors. There's all kinds of ways to adapt information if it has been created in a way that keeps transformation in mind. Of course, handicaps come in all kinds, and I think most people here are pretty young still, but someday you will all be old, wearing glasses, and you may have to enlarge your font size also to be able to access the web, and all these tiny fonts that you see may not be so readable anymore. Another example, CSS, Cascading Style Sheet, that's my domain, that's where I work on a day-to-day basis. Its role in this whole architecture is to help with separating the structure of the information from the style of the information. If you use CSS, you're halfway there. If you don't put the layout in the HTML, you don't use tables for layout, you don't use font tags for the colors, but you do that with CSS, then you have already separated content from structure. And it becomes much easier to change the style for people who don't like that style, who can't deal with it. Separation of style and structure is just a rule of thumb. It doesn't work always, and it's only one of the techniques, but it's the oldest rule of thumb we are applying, and it works pretty well in most cases. The little graphic here shows with and without color. It's just I needed a graphic there. The ultimate in semantic web, so to say, is RDF, the Resource Description Framework. It's the most abstract format we have. The idea here is that every piece of knowledge, every bit of information can ultimately be represented as a network where objects, pieces of information, statements, whatever, are linked to other bits of information via relations, properties. For example, you can have a car is an object, and you can say color red. So the property is the color, and the value is red. You can decompose all kinds of information that way. You end up with a graph, usually much larger than this. And a graph, basically, if you analyze it, you try to linearize it, you end up with triples. An object, a relation, and another object. You make long lists of those. Of course, every bit can be reused as part of another graph, and even a whole graph can itself be an object in yet another graph. For example, if this were something somebody had said, you can see it as one unit of information, attach a relation to it that says spoken by somebody. You can nest all these graphs together. It's very abstract. It's able to express everything if you think hard enough about how to do it. You need lots of what we call ontologies, vocabularies that give lists of keywords, parameters, properties to express things. But in practice, this is not how you are going to write your web page, not anytime soon at least. This is not how people think. When you write an article, you think in titles and paragraphs and lists and images. And that's fine, as long as that format, HTML, SVG, whatever, is well defined. We know what it means, and we can ultimately, if we really need to, transform it to RDF and combine it with other things in RDF and make one big worldwide information graph from it. So I don't expect you to write things in RDF, but we try to create everything in such a way that it's precise enough, formal enough, that if needed, it can be converted to RDF. Okay, so that's a few examples of how the various technologies fit in that model. Next step is, how do we create those? What is the process we use in W3C to come to those standards? Well, first the structure of W3C. At the top of it, in the center, how do you say that, is the director. At the moment, that is Tim Berners-Lee. That's the person who has ultimately the final say about whether something becomes a recommendation, a standard, or not, whether a working group is created, whether something may be published on our website. Of course, that is the process. In practice, he doesn't say anything on his own. He consults, there's reviews going on, he checks the process. But that is the final formal step in every process, everything we create, is the director who finally has to say yes. Around him is the team, the W3C team, of which I am a member. At the moment, a little over 60, I think 67 or so people. That includes people that work on our hardware, on the network, etc., administration, financial stuff. But most of the team is people like me who are technical experts in some area and who are in working groups developing specifications. And of course, W3C is called a consortium, so that means it has members. At the moment, around 400. The members are companies, organizations, non-profit organizations, research institutes. They pay a membership fee, and in return they get the right to participate in the working groups, get information about what's going on internally. Of course, everything eventually becomes public. Usually it becomes public pretty soon. We have a rule that every specification, every draft we write has to become public, or every working group has to publish what they're doing, at least within 3 months. But if you're a member, you can get access to the internal discussions and see things a bit earlier. But most importantly, you can get more influence by actually participating in working groups. So usually we say the fee that you have to pay to become a member is one thing, but the real cost is not that. The real cost is participating. You have to be there, you have to discuss, you have to come to meetings, you have to be on the mailing list, you read your email, answer it, be on the phone. We have phone meetings usually every week. That's where the real cost is. You have to have somebody available who has the time to do that. And I'll show you more of the process in the next slide, and then you can see that it's really a lot of work to create a standard. So this communications that's going on between the members members and others happens in various places. There's face-to-face meetings where people come together, sit around the table and discuss. Most working groups do that 3, maybe 4 times a year. They meet somewhere for 2, 3, 4 days sometimes and discuss. We also have the technical plenary, a big meeting where all the working groups come together and meet each other. It's a lot of fun. It's hard work. It's a bit like a meeting like this here, where everybody comes together and meets in little groups or bigger groups. Creates birds of a feather meetings. It's very important also because working groups have a tendency to try to do everything themselves. Once you're working on something and it's going well, and you see that another working group isn't doing exactly what you think it should be doing, there's always a tendency to try to do it yourself. And that's not good. You have to talk to those other groups and find common ground and say what your requirements are. And meeting face-to-face is often the best way to do that. Teleconferences, most working groups have weekly teleconferences, an hour every week on the phone. There's a mailing list, of course, lots of email going on. And every working group also has public mailing lists where non-members, everybody basically can subscribe to such a mailing list and discuss what's going on, give feedback, suggestions, etc. So the process, this is one way to represent it. From idea to recommendation. The recommendation, W3C recommendation is the term we use for basically a standard. That's the final product. That's a stable specification that we want everybody to use. In this long list here, it's not actually the final step because, well, everybody's human, we are human too, and we make errors, and recommendations sometimes have to be updated. So there were errata, and sometimes there's new versions. But basically, the idea is a recommendation is the final step. This is stable. That's what you have to implement. But in between, there's workshops, working group charters, internal drafts, working drafts. Candidate recommendation is a theoretically stable specification, but it still has to be tested in practice. When it has been tested, there's a final review called proposed recommendation and then a recommendation. If everything goes smoothly, you follow the arrows and you end up at the end. Of course, in practice, things don't always happen that way, and you can go back and skip stages and skip multiple stages and go back a long way, etc. So that didn't look very nice. Luckily, I found a graph that shows a little bit more graphically. Somebody in my working group, Ian Hickson, you may have known, you know his name maybe, put this in his blog to illustrate the W3C process based on the English game of snakes and ladders. Same idea, start with an idea, create a working group charter, working drafts, get lots of feedback, candidate recommendation, more comments, recommendation, errata, and well, maybe at some point you arrive at the perfect web. As you can see, there are shortcuts. You can fall back to an earlier stage if the comments aren't positive. It's not a precise representation of the process, but it's pretty good. You get a good idea of what's involved if you look at this little painting, sketch actually. Okay, so that's the main output, recommendations, but we do more than just create recommendations. Apart from working groups, we have other types of groups, interest groups. They don't write specifications, but they are a platform for W3C members to come together and discuss things. They may work on requirements for a next specification, writing guidelines maybe, seeing what's happening in practice. One example is the math working group who created the math ML, the mathematics markup language. After they finished the second version of that, they decided, okay, now we take a year off. We see how it works in practice. We think there will probably be a need for a third version, but let's wait a while, see what the requirements are. So over the past year, we had no math working group, but we had a math interest group, collected information about people using math ML in practice, what worked, what didn't work, came up with a list of requirements, and probably current expectation is that probably in March or April or in the spring of next year, we'll create another working group who is going to work on the third version of math ML. Coordination groups, well, they coordinate, that's clear from the name. Usually they consist of the chairs of other working groups, and they talk about problems that are common to working groups. For example, we have an XML coordination group where the chairs of the XML core working group are XSLT, XQuery, a couple of others, XSchema. Whenever there is an issue coming up in one working group that needs to be discussed in others, the coordination group is the place to bring those up. They also talk about agendas for joint meetings, task forces when a sub-problem has to be solved with a small group of people. When there's a specification that has to be reviewed by some other working group, that's the task of the coordination group. The latest group we created is an incubator group. Since the I was already taken, somebody suggested, well, let's use an X instead. So we call it the XG now. Incubator group is even more lightweight than interest group. They exist for maximum 1 year. It's a place for members to come together, discuss something, often with the idea of, that's the idea, at least we don't have many of those yet, but the idea of exploring whether there is a need for more, whether there is a need for new specification for a working group, for something. So one thing they can do, for example, is write requirements or draft a charter for a working group, or maybe conclude that there is no need for a working group. The advisory committee consists of one representative from all members. They meet every 6 months and discuss high-level policies. Is the budget still okay? What are the main things to work on in the next year or so? Is the process still working? And we have an advisory board, a small group of people with representatives from the members, and they advise. That's their task. Give advice on the process, basically. So, working drafts, recommendations, candidate recommendations, proposed recommendations. Those are not the only publications. We have more. We also have notes, which can be basically anything. They don't have any status at all. It's just something a working group usually thought was interesting to publish. For example, they can decide to publish the requirements in a separate document, or the history of something, or a primer, an introduction to something else. And we also have submissions, which are publications that are submitted by W3C members and that are, for one reason or another, interesting for us to publish. For example, when we create a specification and there are older versions, proprietary versions that can be considered predecessors of that, it's often interesting to publish those as well, so people can find them at least. That happened, for example, with SOAP, SOAP standard in the web services area. Before it became a standard, there was already something created by Microsoft and others. So they submitted it to W3C, and W3C just became the publisher of that. When we think it's interesting enough to publish, we publish it. So it's not a standard, there's no status, it's just there because it's interesting. And we have actually many of those. So when you see a document on the W3C side, don't think it's a specification. It can be lots of things. It can be a working draft, it can be a note, submission. Only a few of those are actually standards. Okay, so if you followed this, then now you should in principle know how to get involved with W3C. That was one thing I didn't mention there, invited experts. The working groups normally are made up of representatives from W3C members. But not only. There may be people working in their spare time, for example, on something, and they may be experts, they may be very interesting for us, very helpful to have in a working group. But since they are not working for a member, they can't join in that function. So then we have the possibility to invite them. It happens a lot with students, for example. Students have good input, maybe working on open source projects, whatever. And the other people in the working group think, okay, we need that person. We want him or her to be in the group and have access to what we are discussing and make use of their expertise, then we can invite them.
Is there any process for getting somebody invited by an expert?
There's no formal process. It's the chairman of a working group and the team contact, the team member in that working group together decide whether somebody is invited. But usually it's people that are active on the mailing list, on the public mailing list. Yeah. So make yourself visible.
It's the working group chair.
Yeah.
Who makes the decision.
Yes. And in practice, it also turns out to be a good career move because I've had many invited experts when they were still students, and of course, as soon as they were no longer student, they got hired by Google or Opera or whoever. Okay, so to get involved, the public mailing list is open for everybody. Well, everybody should be, but of course you need to be a bit of an expert in the field to be able to discuss, but unfortunately you also need to speak English. Our mailing lists are in English. We try to create everything in such a way that it works for all languages and all cultures, but the development process itself happens in English. So you need to be able to read and write English to be on our mailing list. We haven't found a solution for that, unfortunately. So invited expert, I mentioned that. Of course, if you're working for a company or some organization that is able to join W3C, you can join and then you can go to any working group you like. That's the right of every member organization to join working groups and come to the technical plenary, come to workshops, whatever. That, of course, is the most direct way to have influence, and even more influence if you also volunteer to become an editor of a specification. The editor has the control over what actually gets written. Of course, you're an editor, you're not an author, but still you have some more influence that way. And finally, also not for everybody, joining the team, become my colleague, but that depends, of course, whether we have a vacancy or not. And when the budget is tight, we don't hire new people. Okay, another subject. So now you know the basic process. There's little odds and ends that make the process more complex. When W3C started 11 years ago, those are things we didn't think about. This was the internet. Everything was open. We just came together, formed this consortium, got the important people together and started writing specifications. Okay, we had copyright, that's automatic. Everybody has copyright on what he writes. But we didn't think any further than that. And then we got contributions from other people, and then the question came, well, whose copyright is that? And if we are publishing that and then we want to change it, who has the right to change it? And okay, so that's the first thing to solve. The copyright license, not only on the documents, but also on any software that we give out. Well, okay, copyright is still relatively simple. We now have a license, an open source license on all the software that W3C produces. And we have the W3C document license on all the specifications we write and all the other text we write. Basically, it says you can use it for any purpose, we can't change it. And the open source license, well, it's a normal open source license, you can change it as well. Why? Well, I think it's obvious why we can't let you change the documents with a standard. It's only a standard if it's stable. You can't have anybody change the document and still claim, take the HTML standard, change it a bit and say, okay, from now on, this is HTML. So the license there is a bit different. But you can still republish it. You can publish in a book, give it out in some way, whatever. Patents is a much harder problem. And again, 10 years ago, nobody thought about that. Maybe you have heard of the EOLAS patent that actually appeared on the web about 10 years ago, I think, maybe even earlier, 93, 94 or so. At the time, people just laughed about it. Patents on the web, what's that? But of course, it became a problem as soon as there's more money involved. You have to deal with those. So we had a working group working on it, and we now have a patent policy that's actually quite good. It took a lot of discussion, a lot of this argumentation and convincing, but we now have a patent policy that everything that comes out of W3C is, as far as we have control over that, royalty-free, and even royalty-free in such a way you don't have to ask for a license, you have it automatically. And not just if you are involved with W3C, it's not a patent pool like some other organizations. You have this license even if you're not a member. So if you're an open source project, you can use W3C technology, you can use it, and you don't have to ask for permission to do that. Well, there's still limits to that, of course. We can only control patents that we know about and that are owned by W3C members. If there's some company outside W3C who has a patent and we don't know about it, well, okay, yeah, that's nothing we can do about that. But we hope to have all the important companies and organizations in W3C, so there should be a good chance that what we produce indeed is royalty-free. So, W3C, of course, is not a closed world. Well, we have, I already mentioned, the public mailing list where anybody can join and discuss, but we also have other liaisons. There are other organizations. W3C is certainly not the only organization working in technology standards. There are actually many, very many of them. Mobile phones, the OMA, Open Mobile Alliance, is one that we work together a lot. Internet has the IETF, well known, I guess, ICANN. In telecommunications area, there's the ITU, ETSI, and others. There are similar organizations in digital television, in printer manufacturers, lots of those. We have contacts with most of those, some very intensive, some less. At OMA, already mentioned that because we have this mobile web initiative since a few months ago. We work very closely together with OMA to make sure that the standards for the web are exactly the same as what they recommend for mobile phones. So the mobile phones are an integral part of the web. So XHTML, you may remember there's something called WAP, W-A-P, and they had WML, which was an XML-based format, but it wasn't HTML. So the new, what they call WAP2, is actually XHTML. It's the same as on the web. Well, of course, phones are smaller, so some things don't work, but if you keep to the guidelines, you can create content that works everywhere. So a lot of liaisons going on. There's a lot of work involved in that, but it's important. In Europe, we work together in an organization called the ICTSB, the ICT Standards Board, which has European Standards Organization in it, like CEN, CENILEC, ETSI, EBU, and others. It's set up by European Union to coordinate and divide the work on creating standards. Also W3C is also part of a European project called COPRAS, which is a European-funded project to look at all the other European projects that are funded by the European Union and find technology that can be standardized. It's very interesting, actually. I visited a couple of other projects looking for interesting technologies. So apart from official bodies, of course, the web wouldn't be the web if there weren't a lot of other things going on without any formal organization. And of course, we try to look out for that, get involved with it, help those people either to come to W3C or give our expertise to them. And actually, if you look at the past of W3C, lots of things actually came out from outside, came from things outside W3C. Ping, our first recommendation, was developed on the web, well, on Usenet, mostly by a group of people who weren't satisfied with GIF for various reasons. And it became a W3C standard. HTML also started before W3C was born, CSS also, actually. SOAP came out of some commercial partners outside W3C, etc. At the moment, we're looking at things like microformats, WebForms 2.0, and other initiatives on the web that may or may not eventually come to W3C and become standards. it's not always necessary to have a W3C recommendation for something. Sometimes it's good enough to just have a convention that people use. It doesn't have to be a standard, but sometimes it helps. For example, if there's governments involved, governments like to have to write in laws or other things that things have to conform to something, and then they have to refer to something that's more or less official. Our accessibility guidelines, for example, are referred to in many different laws in many countries. If you write documents for a government, they have to conform to those guidelines. And for a government to be able to claim that, to require that, the guideline itself has to have an official status. Okay, so if you want to read it over, this is the URL. I've probably always also linked from somewhere from the conference site, or you can find it on the W3C site as well. Okay, I think I did well in time, so there is time for questions. There's one over there. Is there a microphone? Yeah, it's working.
As far as I remember, some documents that are published on the W3C site are commented with standard, and others are commented with recommendation. Is this correct?
So some are recommendation and the others are, what did you say?
Standards?
Oh, no. Well, our term is W3C recommendation. That's the term we've been using, well, since we started. But you can consider them standards. Usually the word standard is reserved for official standards body associated with ISO. But in practice, recommendation has the same status. We call them recommendation. There's no standard, nothing labeled standard on the W3C side. Only a recommendation.
Okay.
I wanted to ask you about the direction that W3C is looking, so much of it being semantic web. And this is a very high-level question. I understand that people can consider it reasonable to expect companies like Orbitz, the airlines, to tag their prices with RDF, and I think that's reasonable. But so much of the knowledge on the web comes from individuals, not corporations, things on mailing list archives, things on the PHP manual website, for example. And I'm wondering if the cost of tagging that in a manner that's understandable in the semantic web outweighs my benefit from it, my what I get out of it as a submitter of information.
Mm-hmm. Yeah, it's a good question. It has to do with the usability of the content creation process. That's why I mentioned microformats also. Microformats is a way to add semantics in a very lightweight way. What we're trying to do in such a case, as you mentioned that we're not going to replace HTML with RDF, for example. HTML is fine. What we're trying to do is create it in such a way that, if necessary, it can be converted. You can still use HTML, you can use SVG, you can use a microformat, you can use other things, as long as we know, at least in theory, how to make it formal, if necessary. But no, we certainly don't want people to stop using easy-to-use formats. We want everybody to contribute to the web, and in whatever way is best for them. We just try to give guidelines for how to do it in the best possible way. And some things, with the same effort, you can sometimes do it the right way or the wrong way. So if it's the same effort, we recommend the right way. So if you use HTML, try to use CSS rather than use tables, for example. That's the same effort, but one is better for the semantic web than the other. But no, we're not trying to convince everybody to use RDF. If you can use it, sure, do that, because it fits in the RDF web immediately. It can be searched with RDF tools. But RDF is really a low-level format. I compare it sometimes a bit. Imagine that there were only one programming language in the world. and it was not even a high level one like Pascal or Scheme or Dylan or something. It was PDP-8 assembly language, and you had to do everything with that. You can do everything with that, but you don't want to. So yeah, we have other formats, but we try to make them formal enough to fit in this idea that everything is connected with everything.
Is there any market absentee in your membership? Is there an individual, an organization, an interest group that you would like to cooperate with, which for whatever reason fails or refuses to cooperate?
The sound is a bit bad at this. Can you repeat?
Is there a market absentee in your membership? So that is there any individual or organizational interest group that you would like to cooperate with you, but who for whatever reason fails or refuses to do so, which you would wish to cooperate?
Mm-hmm. There's no absolutes there. There are domains where we think we are underrepresented. We have the software makers, the hardware makers, the telecommunications companies, we have research institutes, but what we don't have enough of is users. We have companies like Boeing and Texaco and etc. that don't develop software themselves, but are using our software and give us feedback from that respect. But we want more. We want the graphic designers. We want people that you apply our technology on a day-to-day basis and give us feedback and actually come into the working group and give us their viewpoint. We have them, but we want more of those. I think that's the main thing at the moment we think we are lacking. No more questions? Okay, oh yeah, there's one more there.
Perhaps you know the Java standard process, the Java community process, and in that process it is mandatory to have some working software that proves that the standard is programmable, doable, that it works. Is this the same for you, your recommendations, or do you think you don't need that stuff?
Yes, that's basically the same. When we started 10 years ago, we went directly from working draft to recommendation, and we considered it was theoretically ready. But later we inserted the candidate recommendation phase, which says, okay, the working group thinks it has done its work, but now we are waiting for implementations. So that in that stage we create test suites, test reports, and usually the requirement is we need to have 2 interoperable implementations, and when that has been shown to work, then we make it a recommendation. That's the normal process. There are exceptions for guidelines, for example. With the accessibility guidelines, it's hard to show that there are 2 interoperable implementations. But usually the guideline, or the rule of thumb is we need 2 interoperable implementations, yes.
Can these implementations be closed source?
Yes, but it must be different. Mozilla and Firefox are not different enough in that respect, but closed source implementations is possible. Yeah, if Internet Explorer implements something and OpenWave browser on a mobile phone, that is 2 implementations. We don't require open source implementations, no. Although we like them very much and we recommend people to use them, but no, we don't require them. Yeah, one more.
What's your opinion on open access to standards? For example, you have to pay to read an ISO standard.
Sorry, I didn't catch that.
You have to pay to read an ISO standard, but you don't have to pay to read an W3C recommendation. So what's your opinion about that?
Well, our opinion is that a standard can only be a standard if it's freely available. It doesn't make much sense if you have to pay a lot of money to get access to it. But, well, that is ISO's business model. They live from what they sell. We decided not to do that. We decided to live from membership fees and subsidies from government. So our standards are open and will always be open, available. And if W3C at one point doesn't exist anymore, you can republish the specs on your site, and you can already do that now, and we hope to keep them available in various ways on other sites, free and forever. Yeah. If there is no more questions, then thank you all for your attention.